Hello, this video tutorial covers Chapter 3 in the EViews Illustrated Guide. Specifically, we will begin working with regression models. Regression is a statistical procedure. Regression analysis is used to estimate the value of parameters within a model. In addition, an analysis generates measures of accuracy of each of the estimated parameters and related information for computing hypothesis tests. The outputs further tell us how well the equation fits the data, or how much is explained by the estimated values, and how much remains unexplained. Finally, the output provides diagnostics to check up on whether assumptions underlying the regression model seem satisfied by the data. To begin, we're going to revisit some data that we saw back in Chapter 1. Okay, so we'll be working with the New York Stock Exchange volume data. If you recall, back in Chapter 1, we created our first regression model by going up into the command line and using the command ls for least squares, right, and defining our model. We're going to do it a little bit differently this time. We're going to use the object tab, okay, and create a new object. Okay, and this new object is going to be an equation. And we're going to go ahead and specify our equation. Okay, so in this case, it's going to be log volume space C spaced at trend. Okay, and so log volume is our dependent variable. C stands for the intercept, and at trend is our command for a trend, a time trend. Okay, and let's go ahead and say OK. And we receive our regression output. You can notice that the regression output is broken into three sections. The top section provides details about the analysis. So it specifically tells us what the dependent variable is, what method we're using, when the analysis was conducted, what the sample period was, and the number of observations. Okay, and this is particularly useful for those situations where you might run a number of models, and maybe a month from now you want to look back at the results, and this helps clarify which results you're actually looking at. Okay. The middle section of the output looks primarily at coefficients for the variable, the independent variable. Okay, and what we want to do in this section is determine if this coefficient for the at trend variable is helpful in the model, if it provides any valuable information. Okay. And to do that, we're going to use the calculated standard error. Okay. If we take the coefficient value divided by the standard error, that gives us the t-statistic. Okay, and this t-statistic will be used in our hypothesis testing. The assumption is that our coefficient is equal to 0. And what that means then is that this variable does not provide any valuable information for the model. Okay, it's not statistically different than 0. Okay. In order to determine the impact of what the t-statistic means, we need to compare the calculated value to the critical value. The critical value is a value that you would find in a t-table. And this process is explained in the Wooldridge text. Specifically, however, you need to know two pieces of information. First, you need to know the degrees of freedom, and you can calculate the degrees of freedom by taking the number of observations minus the number of rows in our second middle section here. Okay, so in this case, it would be 465 minus 2, so our degrees of freedom are 463. The next bit of information we need to know is a confidence level. And for most of the examples we're going to be working with, we'll be looking at a 95% confidence level. Okay? that also is referred to as a 5% level of significance. Okay. Now, if we know level of significance and the degrees of freedom, we can refer to the table and identify the critical value. In this case, the critical value would be something in the neighborhood of 2. Okay, and we can see that our calculated t-statistic is much, much higher than that. Okay, so that means this is significant. Okay, this variable provides some significant information. We can reject the assumption or the null hypothesis that the coefficient on the trend variable is equal to 0. Okay, so that's telling us that this provides valuable information. If it was not significantly different than 0, then the variable isn't providing much information or much useful information, and we in all likelihood could delete that from the model. The final column in the second section is the p-statistic. Okay, and the p-statistic looks at the same information that the t-statistic looks at. It just is presented differently. Okay, and so if we know that our level of significance is 0.05, what this tells us is that if our p-statistic is less than 0.05, then we can reject the null hypothesis of a coefficient equal to 0. Okay, and that means that the at-trend variable is significant and should be included. All right, so the t-statistic and the p-statistic look at similar bits of information, and so the p-statistic is essentially a confirmation of the t-statistic. If we begin looking at the final section of the model, we can see that in the first item that's provided is the r-squared. What the r-squared does is it tells us how well the model fits the data. Okay, and so specifically it tells us what percentage of the dependent variable is explained by the independent variables. Okay, so this is telling us that 85% of the variation in the dependent variable is explained by the independent variable. All right. Before we end, I want to show you a couple of skills that will be helpful for you. Okay. If we look at the view, right now we're looking at the output view, right? But in view, we could also look at the label, right? And you can recall that the label is a place where we could put some notes in there, some descriptions and comments. Okay. An alternative would be to look at the representations, which is the equation. Okay. All right, so this gives us log volume, and it gives us the intercept value plus the coefficient on that trend variable. Right? Or we could go back to the estimated output, which is what provides us with most of our information. Okay. Now, I want to go ahead and save this output. Okay, so I'm going to go ahead and name. Okay, and let's name it output. And we'll go ahead and say OK. And we can see that it generated an equation and that was put right into our work file. Okay, so this equation and output has been saved into our work file. When we go ahead and save our work file, if we close out of it, we could come back and see these results. So that's the end of my first video tutorial for chapter 3. I will pick up next time right where we left off, and we'll look at the meaning of some of these other variable or some of these other statistics that are provided in the bottom section of the output.